Okay, let's go for chapter 4 on fatigues anyway. So this is going to be the new thing that what you guys haven't seen on it before. It's going to be the new things from the beginning that what we talk about chapter 1 on the simple stress and chapter 3 on the combined stresses anyway. So chapter 4 is going to be another new stories anyway, okay? Let's go for the things that what I'm going to initiate on it anyway. That's what it said in here. Machine component. Okay. It said in here. Subject to either repeated loading or fluctuating loading may cause a fatigue failure. Even the induced stress in that corresponding member lower than the used strengths of the member matches. What does it mean here? It mean okay if we just the load is changed with time, repeated loading or fluctuating loading. This means the load or the external loading is not constant anymore. It changes with time. So therefore, it's going to induce the stress inside the member or the stress is going to be fluctuated. It changes with time, of course. So therefore, it's repeated all over and over again. So therefore, the stress is repeated. So therefore, the stress is still less than the use strength of the member or sigma y is due got some failure. So therefore, this is going to be the new things that what the theory that what behind it we cannot use this anymore. So therefore, it's said in here, okay, since the stress in the members, okay, due to the repeat or fluctuating loading is induced and repeat in many durations of time or cycle. Okay, you guys understand about the cycles already, right? The fatigue failure appears in the members. So what does it mean by cycle? Cycle is mean, okay, in machines component or some kind of machine, things like that. Okay, it's gonna be repeated in a cycle, things like that. For instance, like a reciprocating machine, it's gonna work like okay from 0 degree and then turn it up to be 100 degree, 180 degree, and then just come back to zero again. Things like that for Lambda evolution, things like that. Okay, he said it repeat in so many cycle of time. It's gonna cause failures in the member. So he said in here, okay, for example, okay, a loading of shaft subject to bending loading, fatigue fracture begin with a minute. You see microscopic crack at the critical area of high local stress at the outer surface of the shaft and especially at the high stress concentration area at the keyways or reduced shaft and etc. So what does it mean here? It mean okay, the rotating shaft, right? Cause the bending loading, fatigue failure begin with a minute crack. So it mean okay, it's gonna cause a critical stress at the surface area. Because that's why see you got the rotating shaft, right? Because that's why see the bending moment gonna cause there at the surface. So therefore, it's gonna cause the maximum bending moment right there at the surface. So therefore, the sigma gonna be equal to m times c over I. It's gonna u maximum there. So therefore, it's gonna cause the critical area right there at the surface. So therefore, it's gonna cause, of course, the high stress, high likely damage at the surface. And then it said here the high stress concentration area at the keyways or reducer. This is going to be the thing, the highlight things that what I would like you guys to highlight it. The high stress concentration. So it's mean okay. Normally, when you have some kind like machine component, you got to cut it or just reduce the size or abrupt change on the workpiece, things like that due to the machinery, due to the essentials of the reduce the size, whatever, you're gonna have the stress concentration. For instance, see the things that what you've got here. I want to jump over, okay, to the page number 5 there. Stress concentration. Okay, I would like you guys to have a look here. I have a workpiece just on a thin plate, look like that. Okay, I just drew a hole there. Okay, and then I just applied an external force on it, pulling force like that, and then I just cut it. So therefore, if right there at any surface, okay, I got a distribute force, nothing damage on it. It's gonna be distributed with a normal force perpendicular with the stress of sigma equal to F time A. FOA, I'm sorry. FOA all over again. Okay? But at the hole there, at the rim of the hole, I'm gonna have a sigma max right there. Because it's like gonna be abrupt change at the rim of the hole, and then it's gonna be change decreasing all the way and down low, and then it's gonna be down low at the constant of sigma zero, or sigma zero is equal to F over A, of course. Okay, so therefore, this kind of thing, see, if I have a unlimited amount of force applied on it, of course, most likely damage is going to be right there at the rim of the hole there. So therefore, this is a real thing. That was my experiencing the damage likely to be happen. That's what they call this is going to be stress concentration. So in conclusion, we're going to have a most likely damage or the high stress concentration at the rim of the hole. That what I might say that is going to happen there is the abrupt change of the areas anyway. So therefore, in experimentally, we're gonna have a sigma max experiencing there. We're gonna have a case of t gonna be an index that tell you about the sigma max equal to k sub t equal to sigma max over sigma zero. Okay, sigma zero is going to be equal to f over a, of course. Okay, so this have been done experimentally. That's k sub t there. Okay, so therefore, this kind of sense, anyway, we can make experimentally and plot out the graph, look like that, okay, for experimentally. Okay, many expert on machine design, they have it done experimentally. This kind of thing show on the graph there. We have a k sub t on the axis of y, and the axis of x is going to d, diameter of a hole, and the width there, d over w there. You have a k sub t also there. So F is going to be indeed normal force applied on it, the tensile force. So the K sub T is going to be there at the rim of the hole. So please highlight it. K sub T is going to be right there at the bottom part and the top part there. Okay, so K sub T is going to be the most likely damage or most likely critical area of the damage or the critical area, the most likely happen of the stress concentration area. Okay, so this kind of thing is gonna be the things that I want to show you there. Or if we have an ellipse things, okay, we have a formulation of k sub t gonna be equal to 1 over 2b over a, where b and a is gonna be half of the major and minor axis respectively. So this for again, okay, the k sub t there is gonna be right there at the top parts, at the rim at the top and the bottom part respectively. So therefore, this one we have done, okay, and then I collect all the things up for you guys already. That what it might show you there. Everybody just turn it around for the appendix number 3 there, okay. Appendix number 3, okay. You may have a look at it, okay, in the figures, okay. Appendix 3. Everybody just move it up there. Appendix 3. Number 1, please. Have a look at it, please. Number 3, you're gonna have it there. Number 3, okay. Number 1, okay. Number 3, 1, I said up there is gonna be bar in tension with a simple compression with a traverse hole. You may have a look at it. I would like you guys to highlight the terms of bar. Bar is going to be some kind of like a thin plate, things like that. We could apply a tensile or compression. Okay, the K sub T is going to be right there at the rim of the hole on the top and the bottom part there. And second there, rectangular bar is going to be barred again of towards hole. Okay, it's going to undo the bending moments there. See, it's going to be right there again. Okay, K sub T is going to be right there at the rim of the hole. And number 3 is notch. Notch is right there, okay? Notch in Thai language, we call it ba, okay? So there is going to be K sub T is going to be right there at the notch there, okay? And number 4, rectangular bars again, okay? It's going to be right there at the notch again, okay? Number 5 is going to be fillet bar. Fillet is gonna be the things that would be curve all the way. Okay, it's gonna be right there at the curve there. Okay. Number six is gonna fillet bars again. You just highlight the bar. Bar is gonna be the plate. Okay. And number seven is gonna be round shaft. Okay, highlight the shaft, please. With shoulder, shoulder is gonna be some kind like okay, in Thai language, shoulder is going to be kling tok ba. Okay, that's what we just study on the workshops already. Okay, shoulder is going to be reduce the size. Okay, bring it round all the way, curve all the way. So we call it shoulder fillet. Okay, so number seven is shaft. Okay, both sides of shaft. And number eight is shoulder fillet again. Is it under the torque? And then number nine is going to be shouldered again with the round shaft with under the bending. Number 10 is a shaft again, okay, with the traverse hole right there. Number 11 is gonna be under the bending. Number 12 is gonna be some kind like plate under the hole with a hole in there. Okay, number 13 is gonna be the groove, a round bar. Okay, okay, the groove round bar is gonna be some kind like okay, groove is gonna be kung tok long. Okay, you guys just mean. See, we just do this kind of thing for the groove because it's why we're gonna apply the O-ring just on the groove. Okay, if you just see on the workshops already, see, we just do some kind of like a bar, things like that. Okay, we just do a groove on, and we apply the O-ring on it. Okay, and the 13 is a groove under the tension, the groove again with the round bar. Number 13, 14, and 15 is gonna be either shaft or the bar, whatever we want to. Okay, we can apply it on it too. Okay, and then number 16 is gonna be round band again with the traverse hole. Number 17 with round band or tube. We have a hollow shaft inside. Okay, we can use this kind of table for the stress concentration factor K sub T respectively. You guys may see the things that what I just written down there, KT and KT sub S. KT and KT sub S is the same. Okay, I put KT sub S because it's why I would like to emphasize that it's gonna be under the shearing stress. For instance, see, under the shearing stress is mean. Okay, like 15. Okay, number 15, the graph number 15 there, because it's why the graph there is going to KT sub S respectively, because it's why this kind of thing is under the torque, so therefore the KT there is going to be KT sub S respectively. Okay, so the KT and KT sub S is going to be the same thing, is under the loading condition, whatever we want to. Okay, so therefore in conclusion, we just know together already we have the load change with time and we have the stress concentration factor. We got two things there. So let's get back there. Okay. So that what I read out for you guys already. Okay. So the things that what we've got in mind there. Okay. So therefore I got those kind of things. See, this gonna be the load change with time, and then we have the stress concentration factor. These two things is gonna cause very quick damage on the thing. That's what we call the fatigue failure then. Okay. So what we gonna do then? So if just like this, we're gonna have another one rather than the sigma y to be a judgment, to be a hinge for the design then. Okay. The new things that what we got to keep in mind is gonna be another story than what we're gonna set forth for the things that what we're gonna go for is gonna be the SN diagram. Okay, so we stop for a while. We're gonna go next for the SN diagram. What we're gonna be able to find it. Okay, we're gonna stop for a while.